if you are given for two temperature, for two what? Temperature T1 and T what? T2. This you can have what? K1 equal to what? AE minus EAR EA over RT1. This is equation 1. K2 will be what? AE A over RT2. This is equation 2. You will now take logarithm of what? Of both sides. By taking logarithm of both sides, we have ln K what? K1 should be what? Ln A. Take it directly. This should be what? Minus EA over RT1. What I did here. So I jumped the step here. From this to this. So you have this. Call this one what? Equation 3. So yeah, for this, you have ln K2 equal to what? Ln A minus EA over RT2. Equation 4. Subtract equation 3 from equation 4. If you subtract the 3 from equation 4, we have ln K2 minus ln K1 equal to what? If you subtract this will cancel each other. We have ln A minus what? Ln, or let me put it this way. Ln equation 2 A minus EA R T2 minus, we have minus here before, minus EA over R, oh no, oh no, let me rub this thing, this place, I need more space. I will have ln what? Ln K minus ln K1. So, yeah, everything you have here, subtract this from this. You have ln A minus EA R2 minus ln A minus EA RT1. So what will be this now? Ln K2 minus ln K1 to this. If we expand this, we have ln A minus EA RT2 minus ln A plus EA RT1. So this cancel this. We are left with what? Ln K2 minus ln K1 equal what? Will be what? EA RT1 minus E2 RT2. From law of logarithm, this can change to what? Divide. From law of logarithm, it will have ln K2 over what? K1. In logarithm, if you have logarithm of A minus logarithm of B, it will give us what? Log A divided by what? Log B. So this is what I apply here. Yeah? Come on back to here. We have EA over R, it will be what? 1 over T1 minus 1 over what? T2. So this is the formula used to what? To calculate activation energy. We are given what? Rate constant 1 and rate constant 2. Activation energy are the gas constants. And they will give you a rate constant 1 and 2. Then the rate and 2 temperature, you are now asked to find annihilation energy. We apply this formula. Let us look at how are we going to use this formula to solve questions. So solution for these two questions on how to use what? Arrhenius equation. Yeah, what? Solution. The first question here, the following data are found for a reaction as temperature is changed, a certain being kept constant. So we are given two temperatures there. The first one, T1, is 20 degrees C. Compare it to Kelvin. So 273 plus 20 degrees C in Kelvin to give us what? 283. 283 Kelvin. Abi 293 Kelvin. And T2 is what? 30 degrees C, which is what? 273 plus 30. Add it together to give us what? 303 Kelvin. So by conversion of Celsius to Kelvin, you add this to it. And the next thing is what? We are given rate 1, abi K1. Call it what? K what? K1, the rate constant. 1 is 1.5, and K2 is what? 2.4. We are asked to find activation what? Activation energy, which is unknown. Note, this R is constant too. We are given here as 8314 joule per mole per Kelvin. So, to solve this kind of question, we will apply the what? The Arrhenius equation. We say that mean K2 over what? K1 is equal to the what? Minus, no, it's equal to what? EA over R. Everything into what? We have T over T1 minus T over what? Over T2. And this expression, do that this is log what? Log E. Log K2 K1 base E. But to be in log 10, of what? K1, K2 over K1 in base 10 is equal to what? EA over 2.303 R 1 over what? T1 and 1 over what? T2. Yes. That's for what? If we convert this from natural logarithm to base 10, it's the same formula. Let us use this for the convenience sake. Yeah. What is what? Logarithm of base 10, K2 here is 2.4 divided by what? 1.5 equal to what? E activation energy, which is unknown, and that's what? 2.303 R, which 1 over T1. T1 is what? 293 minus T2 is what? 303. By solving it further, divide this by this. Log of 1.6 base 10 equal to what? This EA over 2.303 R and divide this 1 over 293. It will give us what 3.413 times 10 raised to power minus 3. 1 over 3, 1 over 303 to be minus 3.300 multiplied by 10 raised to power minus 3. Yes. So if we subtract from each other 3 times this, it will give us 1.13. Abi? Yeah. Let us put the logarithm of 1.6. The logarithm of 1.6 is supposed to be what? 0.204. Logarithm of 1.6 base 10. 0.204 equal to what? Activation energy E 2.303 into what? We subtract this one from this. We are left with what? 1.13 times 10 power minus 4. 1.13 times 10 raised to power minus 4. Yes. 2.303 R. Yeah. So we let us multiply everything together and insert this R. We are given that R is this. We will now have what? 0.204 equal to the what? 1.13 times 10 raised to power minus 4 PA over what? 2.303 R. But don't forget that what? What is R? R is what? 8.3, 8.314. So if you substitute for R as 8.3 what? 14. From this expression, let us make our what? the formula. The activation energy will be what? 0.204 multiplied by 2.303 times 8.314. Everything over what? 1.13 multiplied by minus 4. This, if you need to play the calculator for this one to know the what? The activation energy. Yes, activation energy is what? Is 34566 joule per mole. That's what? Activation what? Energy for the first question. So let us look at what? The second question. So second question there, we are given activation energy A, which is what? 84 joule per what? Per mole. And the second one is what is the effect or the rate of this? The effect on the rate of raising the temperature from 100 to 110. That effect, the word effect there, simply means what? The ratio of K2 to what? To K1, which is what? Or what? Unknown. Temperature given. T1 is what? Is 100 degrees C plus 273 plus 100 to give us what? 373 Kelvin. The temperature 2 is what? 110 degrees C, 273 plus 110 degrees C. Add it together, it will be what? 3, 8, 3, 300, 8, 3 Kelvin. And the last one, we are given the arc. By applying the formula, logarithm of what? K2, K1 base 10 is equal to the what? EA over what? EA over 3.303 R, temperature T1 minus temperature T1 minus temperature what? T2. Substitute for each what? Value here. You will now have logarithm of what? Then K2, K1 equal to what? We have activation energy should be what? 84K and 2.303 multiplied by what is our R is 8.314. Then over what? T1 is what? 373 minus 1 over what? 383. Substitute for each value. The final answer you get here, it will be the what? The ratio of what? The effective value. So please solve the rest and help me to put the answer on the comment section. So that is how to apply the Arrhenius equation to solve questions. So in the next aspect of chemical kinetics, we are going to treat its factors that affect the rate of chemical reaction, the mechanism of reaction, and the mathematical proving of zero order, first order, and the second orders of what? Of reaction. So let's meet in the next class or next video for the factors that are affecting the rate of chemical reaction. Thanks for watching.